Welcome to Huberman Lab Essentials. Welcome to Huberman Lab Essentials, where we revisit past episodes to distill the most potent and actionable science-based tools for mental health, physical health, and performance. I'm Andrew Huberman, a professor of neurobiology and ophthalmology at Stanford School of Medicine. Today, we're diving into a fascinating and foundational topic, our sense of self, or what scientists call interoception. This concept is about how we perceive and interpret the internal state of our body, our internal landscape, as I like to call it. This includes sensations like our heartbeat, breathing, and gut activity, all of which play a critical role in shaping how we feel, think, and perform. Interoception is not just a biological curiosity. It's a cornerstone of our mental and physical well-being. By understanding and harnessing this sense of self, you can unlock powerful tools to improve sleep, body composition, mental focus, mood, stress regulation, and even recovery from injuries, both physical and neurological. The beauty of interoception lies in its bidirectional nature. Your brain influences your body, and your body profoundly influences your brain. This dynamic interplay is mediated by a remarkable system of nerves, with the vagus nerve at its core, which we'll explore in depth. Our goal today is to unpack the science behind interoception, explain how it works, and provide practical, evidence-based strategies to leverage this system for better health and performance. Whether you're aiming to enhance your focus, calm your mind, or optimize your physical health, understanding interoception will give you a new lens through which to view your body and mind. Let's dive in. What is interoception? Interoception refers to the process by which we sense and interpret signals from within our body. Unlike exteroception, which involves sensing the external world through sight, sound, or touch, interoception is about perceiving what's happening inside: your heartbeat, the rhythm of your breathing, the fullness or emptiness of your gut, and even the chemical balance of your bodily fluids. This internal awareness shapes your sense of self, influencing how you feel physically and emotionally, how you make decisions, and how you interact with the world. At its core, interoception is about communication. Your brain and body are in constant dialogue, exchanging information that determines how you function. This communication isn't just a passive exchange, it's a dynamic system that you can actively influence. By understanding the mechanisms behind interoception, you can learn to adjust your internal state to optimize your health and performance. For example, simple changes in how you breathe can shift your heart rate and mental state, while dietary choices can alter the chemical environment of your gut, impacting your mood and immune function. The importance of interoception cannot be overstated. It's the foundation of everything we feel, do, and are capable of achieving. When your brain and body are in sync, you're positioned to thrive, whether that means staying calm under stress, recovering from an injury, or maintaining sharp focus during a demanding task. Conversely, when this communication breaks down, it can lead to issues like poor digestion, heightened stress, or impaired mental clarity. Today, we'll explore how this system works, the role of the vagus nerve, and practical ways to enhance your interoceptive awareness. The vagus nerve, the body-brain superhighway, the primary system responsible for interoception is the vagus nerve, also known as the 10th cranial nerve. The term vagus comes from the Latin word for wanderer, which is fitting because this nerve is a vast, sprawling network that connects your brain to nearly every organ in your body. Unlike a single, tidy nerve fiber, the vagus is a complex bundle of neurons that travels from the brainstem to organs like the heart, lungs, stomach, intestines, and spleen, facilitating bidirectional communication. This wandering nerve is part of the parasympathetic branch of the autonomic nervous system, which is often associated with rest and digest functions. However, the vagus nerve is far more than a calming mechanism. It's a dynamic communication and control system. It carries two types of information: mechanical related to physical sensations like pressure or movement, and chemical related to the molecular composition of your bodily fluids. These signals inform your brain about the state of your organs, and your brain, in turn, sends instructions back to regulate their function. For example, the vagus nerve tells your brain how fast your heart is beating, whether your lungs are fully inflated, or if your gut is full or empty. It also relays chemical information, such as the acidity of your stomach or the presence of nutrients in your intestines. Based on this input, your brain adjusts organ functions, speeding up or slowing down your heart rate, altering your breathing pattern, or triggering digestion. This feedback loop is what allows your body to maintain balance or homeostasis, and it's central to your sense of self. The vagus nerve originates in the brainstem, a region at the base of your brain, about 3 inches deep if you touch the back of your neck. From there, its fibers extend downward, branching out to connect with organs throughout the body. These connections are not one-way streets. They allow your organs to talk to your brain just as much as your brain talks to your organs. This bidirectional communication is what makes the vagus nerve so powerful. It's the superhighway that links your mind and body, shaping how you feel and function. Mechanical and chemical information. The two pillars of interoception. To understand interoception, we need to break it down into its two fundamental components, mechanical and chemical information. These are the two types of signals that your organs send to your brain, and they form the basis of your internal sense of self. Mechanical information refers to physical sensations, such as pressure, stretch, or movement within your organs. For example, when your stomach is full after a large meal, stretch receptors in the stomach wall detect this pressure and send signals to your brain, which may tell you to stop eating. Similarly, when you inhale deeply, the expansion of your lungs and the downward movement of your diaphragm are mechanical events that your brain registers through the vagus nerve. These mechanical signals are critical for regulating basic bodily functions. For instance, the stretch of your lungs during breathing influences your heart rate, as we'll discuss in detail later. The fullness or emptiness of your gut can drive behaviors like eating or fasting. Even the spleen, which releases immune cells to fight infection, responds to mechanical signals that indicate the body's needs. By tuning into these mechanical cues, you can gain greater control over your physiological state. Chemical information, on the other hand, involves the molecular composition of your bodily fluids. This includes the pH level, acidity or alkalinity of your gut, the presence of nutrients like sugars or fatty acids, or the detection of toxins in your bloodstream. These chemical signals are sensed by specialized neurons that communicate with the brain, often via the vagus nerve, to regulate organ function and maintain balance. For example, the chemical environment of your gut, whether it's too acidic or too alkaline, can affect digestion, mood, and even immune function. When you eat foods rich in omega-3 fatty acids, amino acids, or sugars, neurons in your intestines detect these nutrients and signal to your brain, influencing your behavior and cravings. Chemical imbalances, such as those caused by pathogens or stress, can disrupt this communication, leading to feelings of unease or poor health. The interplay of mechanical and chemical information creates your sense of self. When these signals are in harmony, you feel good, energized, focused, and balanced. When they're out of sync, you might feel off, whether it's a vague sense of discomfort or a specific symptom like nausea or fatigue. The good news is that you can influence both mechanical and chemical signals through simple practices, which we'll explore throughout this discussion. The brain, the command center without receptors. One fascinating aspect of interoception is that the brain itself is an exception to the rule. Unlike other organs, your brain lacks pain receptors and touch receptors. This means it cannot directly sense its own state, whether it's inflamed, injured, or under stress. Instead, The brain relies on signals from the rest of the body to understand what's happening internally. Think of the brain as a command center. It receives data from your organs, your heart, lungs, gut, and spleen, and uses this information to make decisions. For example, if your gut signals that it's full, your brain may suppress your appetite. If your heart rate spikes, your brain might trigger a calming response. This reliance on bodily signals makes interoception critical. It's the brain's only way to feel what's happening inside you. Because the brain lacks its own sensory receptors, it's particularly vulnerable to damage. Neurons in the brain do not regenerate despite some misleading claims about neurogenesis, so protecting them is crucial. This is why the blood-brain barrier exists, a protective gate that regulates which molecules can enter the brain. Later, we'll discuss how specific brain regions bypass this barrier to sense the chemistry of your blood, playing a key role in processes like vomiting and fever. Breathing, a master lever for interoception. Let's start our exploration of actionable tools with one of the most powerful ways to influence interoception: breathing. Your lungs and diaphragm are key players in the interoceptive system, and how you breathe can directly affect your heart rate, mental state, and overall well-being. The mechanics of breathing your lungs are not just two big bags of air, as they might seem. They're filled with millions of tiny air sacs called alveoli, which function like miniature balloons. When you inhale, these alveoli fill with air, causing your lungs to expand. When you exhale, they deflate and your lungs contract. This process is driven by the diaphragm, a dome-shaped skeletal muscle that sits below your lungs, and the intercostal muscles between your ribs. The diaphragm is unique because it's a skeletal muscle, like your biceps or quadriceps, which means you can control it voluntarily. This voluntary control is what makes breathing such a powerful tool for influencing your internal state. When you inhale, your diaphragm moves downward, creating more space in your thoracic cavity, the chest area. When you exhale, the diaphragm moves upward, reducing that space. These movements don't just affect your lungs. They also influence your heart rate through a fascinating mechanism. Breathing and heart rate. The respiratory sinus arrhythmia, the relationship between breathing and heart rate, is governed by a phenomenon called respiratory sinus arrhythmia (RSA). When you inhale, your lungs expand and your diaphragm moves down, creating more space in the thoracic cavity. This allows the heart to physically expand slightly, increasing its volume. When the heart's volume increases, the same amount of blood flows through a larger space, which slows the blood flow. This change is detected by the sinoatrial node, a group of neurons on the heart that acts as its pacemaker. The sinoatrial node sends this information to the brainstem via the vagus nerve, and the brain responds by sending a signal back to the heart to speed up. As a result, long or vigorous inhales increase your heart rate, making you feel more alert and energized. For example, if you take a deep, extended inhale, try it now. Breathe in slowly for 5-6 seconds. You'll notice your heart rate picks up slightly. Conversely, when you exhale, the diaphragm moves up, reducing the space in the thoracic cavity and slightly compressing the heart. This causes the blood to flow faster through a smaller volume, which the sinoatrial node detects. The brain then signals the heart to slow down, promoting a calming effect. Exhales, especially long ones, activate the parasympathetic nervous system, helping you relax. The physiological sigh, a tool for calm. One of the most effective breathing techniques for leveraging this mechanism is the physiological sigh. This involves 2 consecutive inhales through the nose, followed by a long, slow exhale through the mouth. The double inhale maximally fills the alveoli in your lungs, allowing you to exhale a large amount of carbon dioxide. This not only slows your heart rate, but also shifts your nervous system toward a calmer state. To try it, inhale deeply through your nose, pause briefly, then take a second, shorter inhale to top off your lungs. Then, exhale slowly and fully through your mouth. Repeat this 2-3 times, and you'll likely feel a noticeable sense of calm. This technique is particularly effective for reducing stress or anxiety in the moment, as it directly influences the vagus nerve and heart rate. Breathing for alertness. If you want to increase alertness, you can reverse this approach by emphasizing inhales over exhales. For example, take deep, vigorous inhales followed by short, passive exhales. After 25-30 such breaths, you'll likely feel a surge of adrenaline similar to the effect of drinking a double espresso. This is because rapid, deep inhales increase heart rate and activate the sympathetic nervous system, boosting alertness and energy. This technique, sometimes called superoxygenation, or used in practices like tummo breathing, can be a powerful way to wake yourself up without caffeine. However, use it cautiously, as prolonged hyperventilation can cause dizziness or lightheadedness in some people. Why Breathing Matters. Breathing is a unique entry point into interoception because it's both automatic and voluntary. You don't have to think about breathing to stay alive, but you can consciously change your breathing pattern to influence your mental and physical state. This makes it one of the most accessible tools for modulating your interoceptive system. Whether you want to calm down, boost focus, or manage stress, adjusting your breathing can have immediate and profound effects. The gut, a second brain next. Let's turn to another critical player in interoception, the gut. Often called the second brain, the gut encompasses your stomach, intestines, esophagus, and other digestive organs. It communicates with your brain through both mechanical and chemical signals, influencing everything from hunger to mood to immune function. Mechanical signals from the gut. The gut is, in essence, a long tube that runs from your mouth to your anus. Along this tube, mechanical receptors detect physical changes like pressure or stretch. For example, when you eat a large meal, stretch receptors in your stomach and intestines signal to your brain that your gut is full. This triggers a cascade of responses, including the release of hormones that suppress appetite, telling you to stop eating. Conversely, when your gut is empty, these same receptors send signals that drive hunger. This is why you might find yourself rummaging through the fridge, grabbing whatever's available when you're starving. The lack of mechanical pressure in your gut activates brain circuits that compel you to seek food, sometimes without much thought about what you're eating. A practical way to enhance your interoceptive awareness of the gut is to pause for 10-20 seconds after eating and consciously focus on the sensations in your stomach and intestines. Are you comfortably full, or do you feel stuffed? This simple practice can help you tune into these mechanical signals and better regulate your eating habits. Research shows that paying attention to gut fullness can improve your ability to override automatic hunger or satiety cues, which can be helpful for managing portion sizes or avoiding overeating. Chemical signals and nutrient sensing beyond mechanical signals. The gut also communicates through chemical signals, particularly the detection of nutrients. A fascinating discovery from the Huberman Lab at Harvard Medical School highlights the role of specialized neurons called GLP-1R neurons glucagon, like peptide-1 receptor neurons. These neurons have branches that extend into the intestines and stomach, where they sense the stretch of these organs, as well as the presence of specific nutrients, fatty acids, amino acids, and sugars. When these nutrients are detected, GLP-1R neurons send signals to the brain, triggering the release of dopamine and other neurotransmitters that reinforce the behavior that led to the nutrient intake. For example, when you eat foods rich in omega-3 fatty acids like salmon or amino acids like lean meats, these neurons fire, telling your brain, keep doing that. This is why certain foods feel rewarding, even if you don't consciously taste them. Remarkably, these neurons don't rely on taste. Experiments such as those from the Burhey's lab show that even if you numb the mouth or deliver nutrients directly to the gut via a tube, a process called gavage, these neurons still detect the nutrients and signal the brain to seek more of them. This explains why nutrient-dense foods can satisfy cravings even if they don't taste sweet or rich. For those struggling with sugar cravings, this insight offers a powerful strategy. Replacing sugary foods with nutrient-dense options high in omega-3s like fish oil or flaxseed or amino acids like eggs or legumes can activate these neurons and reduce the desire for simple sugars. This approach not only supports better nutrition, but also leverages the gut-brain axis to improve your sense of well-being. The gut microbiome and brain health, the chemical environment of the gut, extends beyond nutrients to include the gut microbiome, the trillions of microorganisms that live in your digestive tract. These microbes play a crucial role in maintaining the proper balance of acidity and alkalinity in your gut, which is essential for digestion, immune function, and brain health. The gut needs to be slightly more acidic than other tissues to function optimally. This acidity creates an environment where beneficial microbes can thrive, while harmful ones are kept in check. When the gut microbiome is balanced, it reduces inflammatory cytokines, molecules that can trigger inflammation in both the body and brain. Excessive inflammation is linked to issues like poor cognition, mood disorders, and weakened immune responses. A landmark study by my colleague Justin Sonnenberg at Stanford School of Medicine compared the effects of two dietary interventions on the gut microbiome, a high-fiber diet and a diet supplemented with fermented foods. Surprisingly, the fermented food diet outperformed the high-fiber diet in reducing inflammatory markers and improving gut health. Fermented foods such as yogurt, kefir, sauerkraut, kimchi, and kombucha introduce beneficial bacteria that enhance the gut's microbial diversity and promote a healthy chemical environment. Practical takeaway is clear. Incorporating 2-4 servings of fermented foods into your daily diet can significantly improve your gut microbiome, reduce inflammation, and enhance brain function. This, in turn, supports better focus, mood, sleep, and immune health. For example, starting your day with a serving of plain, unsweetened yogurt or adding a side of sauerkraut to your lunch can make a measurable difference over time. Nausea and fever, interoception in action while breathing, and gut health are everyday aspects of interoception. Two more dramatic examples, nausea and fever, highlight how the body senses and responds to threats. These processes involve specialized brain regions that bypass the blood-brain barrier to monitor the chemistry of your blood, ensuring your safety. Nausea and the area postrema nausea, often accompanied by vomiting, is a protective mechanism triggered by the detection of harmful substances in the body. At the heart of this response is a small region in the brainstem called the area postrema, located near the chemoreceptor trigger zone. Unlike most of the brain, the area postrema lacks a blood-brain barrier, allowing it to directly sense the chemical composition of your blood. When the area postrema detects toxins, pathogens, or an imbalance in blood chemistry, e.g., excessive acidity, it activates motor reflexes in the abdominal wall, triggering nausea or vomiting. This is why you might feel queasy after eating spoiled food or during a viral infection. The area postrema acts like a vigilant crossing guard, ensuring that harmful substances are expelled before they can cause further damage. Interestingly, the area postrema is also sensitive to psychological triggers. The mere thought of something unpleasant, like blood or vomit, can activate these neurons, causing nausea. This is because the area postrema integrates past experiences with current sensory input, making it a key player in the mind-body connection. To reduce nausea, you can leverage both chemical and neurological interventions. Research supports the use of ginger 1-3 grams, taken as a supplement or in food to reduce nausea by altering the firing threshold of area postrema neurons. Similarly, compounds in cannabis, such as THC and CBD, can modulate these neurons, providing relief from nausea, particularly in medical contexts like chemotherapy. Always consult a healthcare provider before using cannabis, as its effects vary widely. Fever and the ovalt fever is another interoceptive response driven by the detection of foreign substances in the bloodstream, such as bacteria or viruses. This process involves neurons in the organum vasculosum of the lamina terminalis ovalt, located near the brain's ventricles. The ventricles are fluid, filled spaces in the brain that contain cerebrospinal fluid (CSF), which reflects the chemical state of the body. The ovalt neurons, part of the circumventricular organs, lack a blood-brain barrier and can sense toxins or pathogens in the CSF. When activated, these neurons communicate with the preoptic area of the hypothalamus, which raises your body temperature to cook the harmful substances. This is why a fever often accompanies illness. It's your body's attempt to eliminate invaders. However, excessive fever can be dangerous, particularly for the brain, which is sensitive to high temperatures. If your body temperature exceeds 102-103 degrees F38, 9-39, 4 degrees C, especially in adults, you risk damaging neurons which do not regenerate. To safely reduce a fever, focus on cooling the body systemically, particularly through the palms, soles of the feet, and upper face. These areas are rich in blood vessels that dissipate heat effectively. Avoid cooling just the neck or torso, as this can paradoxically signal the brain to increase body temperature further, worsening the fever. Interoception and emotions. The vagus nerve in action so far. We've focused on how interoception influences physical processes like breathing, digestion, and immune responses. But interoception also plays a profound role in shaping your emotions. The vagus nerve integrates signals from your heart, lungs, and gut, creating a holistic picture of your internal state that manifests as your mood. Contrary to popular belief, the vagus nerve is not solely a calming system. While it's part of the parasympathetic nervous system, it's primarily a communication and motor system. For example, when you eat nutrient-rich foods, vagal neurons trigger dopamine release, making you feel motivated to seek more of those foods. When you're nauseous or feverish, the vagus nerve amplifies these signals, creating discomfort that drives protective behaviors. Stress can disrupt vagal communication, particularly between the gut and brain. When you're stressed, the vagus nerve's activity is suppressed, impairing the gut's ability to send signals to the brain. This can lead to poor digestion, bloating, or a general sense of unease. Over time, chronic stress can throw off the gut's chemical balance, contributing to inflammation and mood disturbances. Your emotions are an aggregate of these internal signals. For instance, reading a distressing news headline might increase your heart rate and alter your breathing, which your brain interprets as anxiety. A positive interaction with a loved one might slow your heart rate and relax your breathing, creating a sense of calm. These physical changes, mediated by the vagus nerve, are the foundation of your emotional experience. Remarkably, humans can also sense the internal states of others. Studies show that when you're close to someone, physically or emotionally, your heart rate and breathing patterns can synchronize with theirs even without conscious awareness. This empathetic connection is a testament to the power of interoception, linking your sense of self to the people around you. Enhancing interoceptive awareness to harness the power of interoception, you can train yourself to become more aware of your internal signals. One of the simplest and most effective ways to do this is by practicing heartbeat detection. By focusing on your heartbeat, you strengthen the vagal connections between your body and brain, improving your ability to sense your internal state. Here's how to do it. Find a quiet space and close your eyes to minimize external distractions. Place your hand on your chest or wrist to feel your pulse if needed. Direct your attention to your heartbeat. Try to sense its rhythm without counting. Spend 1-2 minutes focusing on this sensation, noticing any changes in speed or intensity. This practice, often incorporated into meditation, enhances what's called interoceptive awareness, your ability to tune into your body's signals. Over time, you'll become better at noticing when something feels off, whether it's a physical sensation like hunger or an emotional state like unease. This heightened awareness can guide better decision making, from choosing what to eat to managing stress in challenging situations. Practical tools for optimizing interoception. To wrap up, let's summarize the actionable tools from today's discussion, each grounded in the science of interoception. Breathing techniques. Physiological sigh. Perform 2-3 double inhales followed by a long exhale to calm your nervous system and slow your heart rate, ideal for stress relief or anxiety. Inhale. Lymphocyzed breathing. Take deep, vigorous inhales with short exhales for 25-30 breaths to boost alertness and energy. Gut health. Eat fermented foods. Aim for 2-4 servings daily. E.g., yogurt, kefir, sauerkraut to support a healthy gut microbiome, reduce inflammation, and enhance brain function. Focus on nutrient-dense foods. Choose foods rich in omega-3s and amino acids to satisfy cravings and support gut-brain communication. Tune into gut sensations. Pause for 10-20 seconds after eating to sense fullness, helping you regulate portion sizes and eating habits. Nausea management. Ginger. Consume 1-3 grams of ginger via tea, capsules, or food to reduce nausea by modulating area post-trauma activity. Consult a professional for chronic nausea. Explore medical options, including cannabis-based treatments, under medical supervision. Fever regulation. Cool strategically. If your body temperature exceeds 102 degrees F, cool the palms, soles, and upper face to lower fever safely. Avoid cooling just the neck or torso. Interoceptive awareness. Heartbeat detection. Practice sensing your heartbeat for 1-2 minutes daily to strengthen vagal connections and improve your sense of self. Mindful check-ins. Periodically focus on your breathing, heart rate, or gut sensations to enhance your ability to detect subtle internal changes.